What I'm going to do here is go over the PowerPoint slides that are in your My Math Labs Plus program. These are available under Multimedia Material, and I'm going to take them item by item and perhaps give you some tips on it. Hopefully it's helpful. So in Chapter 1, you will have practice and quiz me's on section 1.2 to 1.7. Now, apparently they're skipping 1.1, but I'll do a little review on that for you. So with that in mind, section 1.1, the real numbers. You might say, aren't all numbers real? Well, in the number system that we most commonly use, all of the numbers are real. But in mathematics, it does have a specific definition. Now, what we're dealing with here, as we go into it, are what we call sets of numbers. And in our 1103 class, this is in our chapter 1 also. Now, what are the sets of numbers? Well, the first set are the natural numbers. They usually just use the letter N for it. And that includes or starts with the number 1, 2, 3, 4. These are called counting numbers. And if we were to set up a number line and we put a 0 right there, and then this would be 1, and this would be 2, 3, 4, 5, 6. And then we would extend an arrow indicating it goes on in this direction here. So this is 1, 2, 3, 4, 5, 6. And then once you've set up a pattern, you can use these 3 dots to indicate that the pattern continues. And if we were to graph this pattern on that number line, this natural set of numbers would be a dot at 1, 2, 3, 4, 5, 6. And since we have that big arrow there, it indicates that that pattern goes on. The 3 dots are an ellipsis, and that's used quite frequently to that pattern continuing. So those are the natural numbers. Now, if we just add a 0 to the natural numbers, we get our next set, which we often use a W to indicate it. These are the whole numbers. Now, on the other side of 0, we have numbers that are opposite these numbers, the whole numbers here. So the opposite of a 1 is a negative 1. The opposite of a 2 is a negative 2. And what opposites do, when we add them together, they equal 0. So a negative 1 and a positive 1 is 0. 2 and a negative 2 is 0. So this would then be negative 3, negative 4, negative 5. We've set up our pattern so we can actually use the large arrow indicating it goes on. And this is coming, by the way, from negative infinity and goes all the way up to positive infinity. And we kind of put a comma between the two. So these are those numbers, and the new name we give now to these that all have dots on them, these are called integers. And and we can sometimes use the capital letter I for integers, and that's how it's written. Now, between these integers, there are other numbers. This is where the fractions are found. For instance, 1/2 and 1/3. Now, if we convert 1/2 to a decimal, it goes 0.5, and it terminates right there. If we convert 1/3 to a decimal, you'll notice in your calculator it just keeps repeating 333, so we put a little repeating bar there. Now those fractions that are between these integers, along with the integers themselves, are called rational numbers. So rational numbers are any number that can be written in the form where there's sort of fractions. But remember, all of these other numbers can be written as fractions as well. So we can have, for instance, 6/2. That would be an integer as well as a rational number. So up till now, all of these are rational numbers. Some of them are integers, some of them are whole numbers, some of them are natural numbers. And then we move up to the numbers like this number after 1, not quite halfway, but it's the square root of 2. It's on the number line. If we convert the square root of 2 to a fraction, a decimal fraction, we notice that it keeps continuing, but not in a pattern, and it doesn't terminate. Those numbers, particularly under the radical sign, that are not perfect squares, because if we had the square root of 4, that's 2, and 2 is rational and a counting number, that is a natural number and an integer. But the square root of 2, since it's not a perfect square, we don't have two numbers that when we multiply them together give you a 2. It gets close, but it just keeps going on and on. These numbers that don't terminate or don't have a repeating pattern are called the irrational numbers. And we could use the first part of that to indicate it. Now, all of these numbers are on the number line. And all of these numbers on the number line make up what we call real numbers. And there's the official definition of what real numbers are. They're found on the number line, and they fall into these various categories. Now, keep in mind that 4 falls into all of these categories except irrational. All of the numbers, including the square root of 2, are real numbers. They're all on the number line. Another famous irrational number here is pi. That's also considered irrational. Now, when we think of our arithmetic system of dealing with numbers, there are certain properties that they have that you may have heard of. Again, we're not featuring this in 1108, but it has been used in 1103. So just to review them a little bit. Now here we say if we're adding a plus b, we can also add b plus a and get the same answer. This is called the commutative property of addition. Here, if we multiply a times b or b times a, again, it's the same value. Commutative property of multiplication. Here we have the letters A, B, C, A, B, C. But notice we're grouping A and B together here. Then we're grouping B and C together. This is called the associative property. You could add these two and then this one, or these two and then this one, get the same answer. So this is a legal process. It's the same is true for multiplication, just grouping them differently. Now we have two identity properties. One of addition, that's this one. You can add 0 to any number and it just stays the number. Okay? Now the multiplicative identity is you can multiply anything by 1 and it's still the same value. Some of these hopefully are triggering memories. And you say, oh yeah, I remember that. Okay, let's go on here. Now the inverse property. Now if you have a value A and you add it to negative A, the sum is 0. This is the additive inverse, or the opposites that we spoke of when we talked about this earlier. And so is negative A plus A. So this is the inverse of addition, the additive inverse. If we add a number with its opposite sign, the results is 0. All right, now another one here as we look at it. And if A is over 1, every number is over 1, A over 1 times 1 over A. Notice as we multiply, the A's cancel out here, and we end up with 1 over 1, which is 1. If we have 1 over A and multiply it by A over 1, again, the A's cancel out, and we get 1. Whenever we multiply something that the product then is 1, we've multiplied it by its reciprocal, or the multiplicative inverse. Perhaps you've heard the reciprocal, you just flip it over, and the product, remember, is a positive 1. And the distributive property is another one we use commonly. We just distribute the A over addition to the B and the C, and we get this. We could also do it sort of backwards, and we get that. Now notice if we take the A out of this, which is called factoring, we factor out the A, we then get this. So the distributive property distributes, the factoring property takes it out. We'll be using that. Now, parentheses are a grouping symbol, along with a fraction bar, brackets, even the square root sign, the radical sign. These are grouping symbols. That means that anything that's within a parenthesis, or even absolute value, or under or above a fraction bar, this must be done first to simplify. Order of operations. Please excuse my dear Aunt Sally is an acronym to show what's here. We do what's inside parentheses. Raise to exponent powers. Then multiply, divide as we get to it. If division is first, we do division first. Then we do addition, subtraction, in the order we come to it, from left to right, in this order. This is order of operations. okay? And this symbol here is less than. A is less than B. So on a number line, see if I can make a number line. There we go. A would be to the left of B. So we say A is less than B. B is to the right. So reading it this way, B is greater. The open side is toward the greater. The point is toward the left. So we'd say B is greater than A. It's the relative position on the number line. Anything to the left is less than anything to the right. Now this one states that A is less than or equal to B, and B is greater than or equal to A. Now, there is a difference in this that we'll be showing you as we go on, how we make a graph of this or show interval notation. So here we want to graph all real numbers of x such that x is greater than 1 but less than 5. How do we do that? Well, if we make a number line, since this is only an inequality sign and it does not equal, we use a parenthesis. If I can make a parenthesis, there we go. And that has to be right there we go. Okay. That parenthesis is kind of a funny looking parenthesis. And then we darken it in to indicate all real numbers between a 1 and a 5. And because it's an inequality sign, the 1 and the 5 are not included in that. It's what comes after 1 and what comes before 5. And they're showing that. A parenthesis is used. So there's the inequality, and there's the type of sign that is shown. If something is included in the set, the A is included, we use a bracket. B is included. Here A is included, we use a bracket, but B is not included, we're using a parenthesis. And here A is not included, starting after A, so the parenthesis is used when something is not included, but everything between them. Okay? Now these are things you'll be practicing in your work. They're teaching it here, but we want to keep an eye on it as we move along. Now this is a little bit challenging here as I look at it. Here's saying the absolute value of any number is its distance from 0 and is a positive number. So they're saying here the A was positive, it's greater or equal to 0, and that equals its positive value. Here they're saying what would have been included in the absolute value sign, if it were a negative in there, comes out as a positive. All absolute values, when we do this operation, come out as a positive value. So if inside here was a negative A, it would come out as a positive A. To me, I think when they made this slide, they have this reversed unless they're thinking of something else. Anyway, okay, that was section 1, and that took 20 minutes. So let's do a little review of section 2, and that will be like one lesson. Okay, this will be a short review of polynomials. Again, you did much of this if you took the earlier math or you placed into this section. Here they're going to review exponential notation. So if we have the letter A, that stands for some number, that is considered the base. And the number of times that base is multiplied by itself, that would be the n factors. You raise that n to that power. That is, you multiply that base by itself that number of times. Now, if you have, let's say, a to the second times a to the third, to get your result, you're just going to add these exponents. And this is the rule. To multiply variables with the same base, you just add the exponents. Now here you're raising a power of a power. So to do this type, when it's inside a parenthesis and then there's another exponent outside, you don't add, you multiply the exponents. And there's the rule. And again, in your practice and quiz me, you'll be doing that. And any time you see an exponent that is 0, a to the 0 power, that equals 1. And you get to that. Let me show you the background of that. Suppose you have a to the third divided by a to the third. Now later they're going to tell you that you do this by bringing this exponent up across the division bar. The exponent changes its sign and becomes a negative 3. So what is that going to become? Well, that's going to be a then to the 0 power. But what is a to the third divided by a to the third? Or if it was 8 divided by 8, what is 8 divided by 8? Or what is any number other than 0 divided by itself? It's 1. This is 1. So by doing it this way, if we get a to the 0, what does a to the 0 refer to? A 1. And that's the definition of it. Anything to the 0 power is 1. And this is proof of it. Okay, we want to look over now what happens when you're getting rid of parentheses, or as they say here, eliminating a parenthesis. Now here's a parenthesis and there's no sign in front of it. So the rule is just take away the parenthesis. No sign in front of it, just take it away and it stays the same. Now in this case where you have a parenthesis, but this has a negative sign in front, how do you eliminate the parenthesis? And the rule is you change this to a positive, and then inside you change each of these signs. So this used to be a positive, now it's a negative. This used to be a negative, now it's a positive. This used to be a positive, now it's a negative, and just take away the signs. So that's the basic rule. If you have a negative in front of a parenthesis, take away the parenthesis, change all the signs of the terms inside the parenthesis. And there, that was a positive. It's now become a negative. That was a negative. It's now a positive. This was a positive. Now it becomes a negative. And you would just group like terms. Okay? So here they're putting all the like terms together. Like terms are defined by the variable being exactly the same. Those are the like term items. And you've simplified by combining like terms. Okay, we'll call that section, that's 25 minutes long, one little lesson, and then we'll pick up on the next few.